Welcome. Hello.
Hello.
Welcome to You
Welcome
Choose.
to
Welcome.
You Choose. Welcome.
I'm being punked right now. Great. I'm not surprised. Welcome to You Choose, a choose your own adventure show through the CNCF landscape. So glad you're here. We're in chapter 4 right now, where we're navigating our way through all of the observability tools, and it's spicy. We're just walking right into some history, man, between projects, and we're just gonna keep going through.
This season is boring. None of our guests so far ended up in a fight. Previous seasons were
And
more interesting.
and
I
I
expect
thought we might,
Cortex and Thanos today kind of to start yelling at each other.
yeah.
It's mandatory.
If there aren't tears, did we even really have a show?
I mean, the only other option I have left is for me to yell at everybody. So kind of like that's useless.
One person needs to cry, or Victor will make all of the rest of us cry.
Exactly.
Someone needs to sacrifice themselves. Okay, so last week, so this week we're going to cover metrics. We have a guest here representing Prometheus, one representing Thanos, and one representing Cortex. And then last week we did an episode about open standards, and we had Prometheus and we had open telemetry. So what's something you learned last week, Victor?
I mean, not necessarily that I learned last week, but solidified my impression that both of them are unavoidable.
Yes,
I
that was
cannot have
even
my Kubernetes cluster without Prometheus without Prometheus format for metrics, querying metrics especially, right? Doesn't have to necessarily be Prometheus, but something in Prometheus format. I don't think anybody said that, but simply because at least one of my tools works only with Prometheus in my cluster, right? Kind of, it's unavoidable. And then, open telemetry, it's avoidable, but then you're a fool. Kind of like, what the heck are you doing, right? So
it was even the closing statements of the guests. The after even a pretty heated discussion, our Richie H, the Prometheus guest, his closing statement is like, you can't do metrics without open telemetry. And Austin Parker, representing open telemetry, said you can't do metrics without Prometheus.
That's the boring part I was talking about. Instead of them saying, no, this is stupid, you are stupid, your project is stupid, your format is stupid, they were about to sing Kumbaya for all of us. Kind of like, that's unacceptable. Unacceptable.
Actually, the thing that they really disagreed on was something I hadn't even really thought about, and they really disagreed on whether
they were faking this agreement. They were faking it. They were just kind of holding hands. Unacceptable.
Do you know what the end of my sentence was going to be?
I don't know. I'm not listening.
Okay, I suspected. Well, the thing they disagreed on is whether you should push metrics to your collector or whether you should pool metrics, and that was a big conversation for them. But as for me, being kind of brand new to the observability, I didn't understand. I understood what they were talking about, but I didn't understand the why, or it didn't feel like such an urgent discussion for me, we'll say. But one thing I was trying to understand as part of the episode, and maybe didn't, one thing that's hard as someone new is Prometheus and OpenTelemetry are each so many things. Like OpenTelemetry is a specification that became a standard, and now there's software built on top of it. And the software is APIs and SDKs and collectors. And so when people were saying you have to have OpenTelemetry, I'm wondering, I guess still wondering, like, which part of that do you have to have?
I mean, you're almost inevitably going to use OpenTelemetry API, which is a standard, right? Same thing, more or less.
Okay, the API.
Now, whether you use one of the OpenTelemetry, let's say, projects or sub-projects to, let's say, collect those traces or whatever you're doing and so on and so forth, or not is a separate question, right? So you might not use implementations developed by them, but you're going to use standard of the project in any case.
And then similarly,
Datadog, right? Datadog is now going to be implements OpenTelemetry, right? That's how they collect and expose data and so on and so forth. And that wouldn't be implementation of OpenTelemetry, but yes, to the standard, right?
Yeah. Okay. And similarly, Prometheus, when you say Prometheus, it sounds like one thing, but really it's like exporters and or a library and then a scraper and then like a rules engine and then a storage later and then querying. Like there's lots of different software components that all are called Prometheus, not to mention the standard open metrics. The format.
But it's also similar situation, right? I could put, for example, Victoria metrics in my cluster, which is not Prometheus implementation, right? It's a separate project. Yet I will be using the Prometheus standard for querying metrics so that the rest of my applications work in the same way because they expect Prometheus, right? So I might be using their API without using Prometheus itself.
And okay. And then it also sounds like both projects are growing so that they're kind of starting or maybe have been stepping on each other's toes, or they do. There's a lot of overlapping functionality. So Prometheus has some sort of Prometheus agent, I think, that can do like the collector part that OpenTelemetry can do. OpenTelemetry definitely has some sort of metrics situation that's OpenTelemetry specific. Which I think just tends to happen in the CNCF altogether. As projects get big, they start to converge. So I think we're seeing some of that too.
If you remember the episode when we talked about GitOps, right? And then, Flux does this and Argo CD does that. But Argo CD, by the way, does that as well now. And Flux as well does it as well. So kind of like we all do the same thing and then sometimes not. Yeah.
But then they still could agree, much to Victor's disappointment, that you need both. So that episode wasn't actually even a vote because it is pretty, everyone can agree you need both. So we didn't want to have a situation in our demo building where we could only use one and not the other.
Yeah, especially since the choice was really, that episode was first and foremost about the standards, about the APIs rather than specific implementations. And then depending on the tools that people choose throughout the rest of this season, they might go one way or on the other, and most likely both anyway, but no choice yet.
We'll see. It's up to y'all. So now that brings us to today. We're going to talk to 3 projects, Prometheus, Thanos, and Cortex. And what should we be thinking about when we're evaluating these 3 projects?
I mean, and this is my not necessarily educated response, right? We're talking about Prometheus, and Prometheus. And the major differences are in the way how it scales.
Yeah.
There must be many other reasons and things, and then guests are going to explain, but we are talking about variations or additions or what's not on top of Prometheus.
Yeah.
Prometheus itself, depending on the guest.
And my understanding, and we'll get clarification from the guest, is that Prometheus is meant to run as a standalone. And then as you want more instances, whether you're scaling or auto scaling, then you have more factors to consider. Like, for example, how are you going to query across all of those instances? So it's not a matter even of simply running it. And then how do you have a high availability? Like as you are using this at scale, you start to hit up against some problems.
So there are 2 distinct things there, which you might loosely say scaling, right? One is how do I run one or multiple replicas of Prometheus in my cluster, right?
Yes.
And the other one, if I have many clusters, I might be running Prometheus in each of them, and do I keep it separate and treat each of them as a completely separate entity? Like, hey, If you need something from this cluster, go there, and so on and so forth. Or do you somehow unify all those Prometheuses in distinct clusters into one single layer?
One of my questions at the end is going to be, is it Prometheuses or Promethei?
Well, you're the native English-speaking person here, so if I need to answer linguistic questions with me, we have a real situation over here.
And that actually brings up a great point. If you have any questions, those of you who are here with us live, thanks for being here, by the way. If you have any questions, please ask them ASAP. We tend to kind of go in order. And so if you want your question to get answered, ask it sooner rather than later. Another thing about... Okay, so we've kind of talked about scaling and a few different issues that will happen when you scale your Prometheus. Another thing is like short-term storage versus long-term storage. I think that some of these tools that build on Prometheus, that's another problem that they're solving. That's something I'm going to ask too, is like, why do you need long-term storage? And why do you...
If they give the answer, if guests give the answer, I suspect that they will give, then they will have a fight, but now not between them, but between me
with
and
you?
Depends what they answer. Let's see.
I can't. Well, all right. So I'm gonna bring everyone on to say hello. Let's see. Do you know what I have to say? Our guests are all very sweet and nice people, and we've been really going on about.
The end of the episode.
So let's bring on our first.
Out of closet situation. Yeah, you'll see.
Let's bring on our first really kind and wonderful guest, and that's Iris. Iris, hello, welcome. Thanks for being here.
Hello, everyone.
Will you introduce yourself, please? Let's go. Will you introduce yourself, please?
Absolutely. Hello, everyone. I'm Iris. I'm actually based in Porto as well. I saw some of the comments that were saying. I'm a senior observability engineer. I work at Miro, and my professional life is about observability. I wake up in the morning, I talk observability. I close my computer, I talk observability. So I've been working for a very long time. And my job specifications are to build an observability platform, to make them as good as possible, and to empower our teams to use them as much. So let's say that I know what I'm talking about when we're saying about observability.
Awesome. I can't wait to learn about Prometheus from you in just a bit. I'll see you here in just a minute. All right, Saswata. Welcome, friend. Thank you for being here.
Yeah, thanks for having me. And yeah, I'm ready to throw hands as well. Yes.
He just said that in the nicest way. Someone who wants to fight doesn't say it like that. Will you introduce yourself, please?
Sure. My name is Saswata Mukherjee. I'm a software engineer at Red Hat and currently based out of London. I've been with Red Hat for about 3 years now, and I primarily work on monitoring platforms, largely based around Thanos. So we run Thanos as a service internally, and different teams send us metrics that they can query from us. And we also ship Thanos as part of some of our multi-cluster offerings for OpenShift. I'm also a maintainer of Thanos for nearly a couple of years now, and was previously a GSOC mentee under it. I help maintain certain other CNCF adjacent Go tools and libraries, and from time to time mentor different Thanos LFX projects as well. So yeah, that's me.
That's awesome. I can't wait to learn from you soon. Thank you, Saswata. All right, last but not least, Friedrich, hello.
Hello, hi, how are you? I'm not the fighting type, so we'll see. Yeah.
Basically, so the most muscled person in come on.
No, it's not gonna happen.
He just casually flexes his bicep as he says it. I'm not a fighting type.
Well, I'm Friedrich Gonzalez. I'm a software engineer. I've been doing all kinds of things the last 6 years, mostly on Cortex, right? Cortex metrics is what's been. I'm a maintainer for Cortex. I'm happy to talk about Cortex and Thanos. We're all together solving the same problems for users, and Prometheus as well, right? So it's a really exciting conversation. I'm happy to be here.
Thank you so much for being here, friend. We'll see you in about 10 minutes. All right, Iris, are you ready to go? We're going to start the timer more or less when you come on the screen. So I'll get your presentation up, and here we go.
Well, hello everyone. Again, it's Iris. So I said that I'm ready to fight, but to be honest, not really, because there is really no fighting when it comes to Prometheus. Because let's say that all metrics observability right now is kind of built on top of Prometheus. It's used as the main standard. But yeah, I heard so many nice things in the beginning that I didn't think before the presentation. So I'm going to go a little bit off my presentation here. Bear with me, please. I talk a lot. And I wanted to open this presentation by saying that just like the god Prometheus brought fire to people, Prometheus, the technology, the observability technology, brought metrics to us. And yeah, it changed the world of observability, in my opinion. So I wanted to start by just saying for those people that have never heard about Prometheus, because it is surprising, but it is true that there are a lot of people that don't know what Prometheus is. And it is like an open source monitoring and alerting toolkit. The best way to have this presentation would be Prometheus and his friends. But because his friends are my competition today, I'm not going to talk about them. So I'm going to go only on the Prometheus part. So what does Prometheus do? It collects metrics by scraping endpoints exposed by targets, and it uses a pool-based model. It pulls metrics at the interval that you yourself can configure, which is very convenient, or push-based, because sometimes you can see that it says that Prometheus could be pull or push-based, but push-based is just another friend of Prometheus, which is Prometheus push gateway, which is a gateway in the middle that Prometheus scrapes in an interval. So yeah, I think the consensus is that it is a pull-based tool. So what is the data flow of Prometheus? It identifies targets using static configurations or service discovery, which is very cool, and I'm going to talk about it in a little bit. It collects metrics in a time series format, and it stores them in time series databases. Usually, depending when you're running it, it can be different backends. So the good thing about Prometheus that always makes me talk a lot about it is that Prometheus, because it's been the standard for so long, it has a lot of configurations, a lot of friends, a lot of other technologies that it is compatible with. For example, target discovery. It doesn't matter where you're running Prometheus, you will always have some sort of mechanism that is you will be able to pull metrics from. It can be static, which is like the most basic. You just add an endpoint there, it's going to scrape it. But it can be discovered through, for example, if you have EC2 machines, it has a configuration, an integration with AWS. Through DNS, Kubernetes SD configs. It just gets there and collects all the data from the endpoints that you have. And Azure SD configs. These ones are the ones that I've used more frequently, but there is a lot more. If you go to the Prometheus documentation, there is a huge list of them. There is a lot. I don't even know where to start. So there is a chance that there will always be a configuration that you can use. And if not, because it is open source, you can always contribute one. So that's the greatest part of it. So another good thing about Prometheus, again, with the friends, let's start with the data format. We all know that the Prometheus format is very easy to read, but it is the standard in the industry right now. I know it is being challenged a little bit by OpenTelemetry format, and there is a lot of discussion around that. But at the moment, everyone tries to preserve the Prometheus format, not only for querying purposes, but for alerting as well. A big movement in the observability world right now is using APM vendors, which are, of course, you have to pay for their processing power. And surprise, surprise, of course, their standard as well as Prometheus. So as long as you are using Prometheus standard, you can move from one vendor to another, keep an on-prem solution. You will always be covered when it comes to your dashboarding, to your querying, to your alerting, to your auto-scaling capabilities. So all great. So visualization. I just wanted to mention very little that it is using PromQL for filtering, aggregation. You can use Grafana together with it, and it alerts through Alert Manager, which the rules are evaluated by Prometheus. And then once they're fired, they're pushed to Alert Manager, which has configurations and integrations with PagerDuty, Slack, Ops Genie. Yes, almost there. And the best part of it is Prometheus in Kubernetes, which is the operator. So we have the Prometheus operator, which is the best of Kubernetes and Prometheus together. So you deploy an application, it has a service monitor to it, it is automatically onboarded. Alerting rules automatically onboarded. Also recording rules for your metrics automatically onboarded. And yeah, it comes with the challenges, but it is what it is. It's the best.
Oh, I'm the worst. It's so much more rude than your gong. I can't. It's terrible. You're muted, Victor.
Your real personality is surfacing finally. You cannot hide behind I'm nice Whitney show. Good.
I will. I did my best
By
to
the way,
communicate.
you know, a few months ago I was guest on your show in CNCF. I'm not coming anymore now that I see the new Whitney.
On Cloud Native Live, I'm just going to start just cutting people off right when they're saying their kinds goodbyes. Yeah, great. I'm going to take the nicest guest possible, which not you, but the other ones, and cut them all off. So let's so just a reminder, please ask your questions, and now we're going to do our next guest, Eswata. And we're going to start your time right now.
Hi. Okay. So let's get started. So yeah, to give a very brief summary of Thanos and be well under 5 minutes, I think we can start by explaining Prometheus a bit. So one of our co-guests really explained Prometheus nicely, but yeah, in general, the functionality of Prometheus can be divided in like 4 different segments, right? You have the query engine for processing queries. You have the scrape engine, which scrapes your applications, gathers data and puts it in a time series database. You have the rule and alert engine, which basically sends alerts by processing certain PromQL queries. And you have something called as a compactor, which is sort of like a background routine that compacts your TSDB blocks into bigger blocks. And Thanos basically allows you to scale all these parts or functionalities of Prometheus. And it can be termed as a sort of distributed Prometheus++, and that's for good reasons. Thanos' goal is to provide a highly available and scalable set of components to compose a distributed Prometheus-based monitoring system, and it tackles many of Prometheus's challenges by integrating features for global view, long-term storage, and even things like multi-tenancy. So let's see how it does that. So with Thanos, you can choose to gradually adopt Thanos components into your existing setup. So one of the first steps we usually recommend people to take is, while scaling their monitoring, is to adopt the sidecar architecture. And here you run a Thanos sidecar component besides each of your Promethei, which reads data from the Prometheus server and serves it up for querying using a Thanos querier. So you can attach multiple different metric backends to querier, and it will fan out your PromQL queries to all those different metric backends, with this particular backend here being sidecar. And this is something that you can actually do with Prometheus operator, because Prometheus operator by default ships with the sidecar that you can enable, right? And in this way, you can sort of have a global view of your entire infrastructure. And you can also then leverage querier using a Thanos ruler component to actually evaluate Prometheus format recording rules and alerting rules globally across all of your infrastructure, which can really help for maintaining things like SLOs or alerting for fleet-wide issues. And one of the benefits of the sidecar is that it can ship all the data from Prometheus directly to any sort of object storage in the form of TSDB blocks. And this makes storing long-term metric data, say over a year's worth, way cheaper and actually practical. And you can use a Thanos store gateway component to expose this data as a metric backend that the Thanos query can query. And if you remember, we discussed something around Prometheus compacting its TSDB blocks to make queries more efficient. So we can actually do that at the global level here on the blocks stored in our object storage buckets now using the Thanos compactor. So it is responsible for compacting lots of smaller blocks into larger blocks with larger indexes, which makes querying a lot more efficient. And it is also responsible for something called as downsampling, which basically means that it would reduce the number of samples that you have to, say, one sample every 5 minutes or one sample every 1 hour instead of one every 30 seconds. And in this way, you can practically query for more than a year's worth of data without melting your browser. And finally, you have a somewhat unique component known as Thanos receive. And so with this component, you can ingest Prometheus role trade requests from multiple different Promethei and store them in TSDBs, which you can, again, query using Thanos Query. And so receives also upload blocks to object storage for long-term storage. They implement multi-tenancy, and it takes scalability seriously, and you can run it in sharded form as a set of nodes in a hash ring. We also have a split mode now where you can run receive router nodes with certain ingester hash rings as well. And an architecture like this can really help when you need metrics from Prometheus that you don't own or aren't running, or as a sort of the monitoring as a service mode, let's say. So with all these components, you can run some flexible but complex deployments as well, such as sidecar plus receive. And such setups can scale to billions of time series for you to store and query. So yeah, thank you.
Oh, it's over before even the
Yes.
30-second mark. Good job. Wonderful. Thank you. And we'll see you soon for the question and answer part. All right, I gotta reset the timer. Okay. And here we go. Friedrich. Hello, welcome.
Hello. Yeah, no, very nice. Very
Go.
interesting. Yeah, so let's talk a bit on Cortex, right? We don't have a lot of time, but I quickly gonna show you what Cortex does. Is a horizontal, scalable, highly available, multi-tenant, long-term storage for Prometheus. This is the web page. You can go to it and you can learn more about it. The first thing I recommend when you want to learn more about Cortex is the getting started. The reason why I want to call out the getting started is because it has a set of steps how to run Cortex locally, and it's pretty nice. It used to be like people say, you have so many components. How do you run those components? So nowadays, running Cortex is really easy. So you can just run those Docker compose. To show you what those components are, we have an architecture diagram here. The architecture diagram is fairly similar to Thanos. I want to point that out. We do have distributors, we have ingesters that receive the metrics, and those components scale horizontally. And we also have a block storage here on the side, right? That where we send the long-term storage, the metrics, right? We also have a alert manager, ruler that has that configuration about the alerts, right? And the configuration. But let's see how that looks like. I wanna go quickly on that because when you show a diagram, it's kind of hard. I run this Docker Compose. Luckily it works, the demo. And it basically, you can run it yourself. It just runs 4 components. Those 4 components are Cortex, Grafana, Prometheus, and an S3 bucket, software or block storage software. And they're all connected with each other and pre-configured for you. The reason why we're running just one is because Cortex has this feature that can run all the components just in one. So that's pretty nice for setup for demos, right? So you can try all the components in one, right? And I already started it, and yeah, it's been running for a while. And where the metric starts is in Prometheus, right? So if you're familiar with Prometheus UI, you can see the configuration for Prometheus and the target sphere. This Prometheus is scraping Prometheus and Cortex. So we're getting metrics from Cortex itself, and we're getting those metrics inside Cortex. The way we send them to Cortex is you don't have to put anything in Prometheus. You just put a configuration, and that is the remote write, right, in this case. I do have to say we also support collectors. So if you don't want to use Prometheus, you just want to use collectors, you can just configure a collector and remote write as well to Cortex. We have support also as well for OTLP, which is the OpenTelemetry standard for transmitting metrics as well. So you can use that. So if you don't want to use Prometheus with Cortex, you can also do that too. So moving here, as you can see, Cortex doesn't have a UI. Thanos has a UI, Cortex doesn't have it. It's just an API. So, but you can use Grafana or Persis or any kind of dashboard tool that's compatible with Prometheus to query the metrics. yeah, so we're going to see here some of the metrics that we're getting. This is also in the demo, right? So, and here we see how the metrics are getting into Cortex, and this is all provided for you. You just have to start it up to get this visibility into. So we're using Prometheus to monitor Cortex and ingesting those metrics. We also have configured here the multiple data sources, and you can see here we have tenants configured for each tenant, and in each tenant we have configured each the access to each tenant, so you can play with that as well. I'm running out of time, but quickly back to I think I said pretty much everything that I wanted to say. Just going back here, you can see where the tenants are configured, right? So you have multiple tenants configured. So yeah, you can play with that. That's what we have.
All right.
Yeah, thank you.
Thank you. Instead, you're going to just stay on the screen with us, and I'm going to bring on all the friends. Hello. Welcome back. That was a great job, everyone. Thank you for sharing your time and expertise with us. We have some really more comments than questions this time around. Dan McCormack, you said, I'd like to hear more about that functionality, but I don't know what functionality was happening at the time you wrote that comment. So if you want to rephrase that in the form of a question, we would love to answer it.
I think it's about, I mean, my understanding, he might correct me, is that it's about his previous comment when he said that Prometheus cannot have long-term storage and so on and so forth.
So, and that's something
he heard, hey, but Cortex and Thanos do. So,
yeah, there's a lot to talk about. So long-term storage. First, let's talk to Iris about how long can you store in Prometheus without the help of Thanos?
No, stop. I want to hear first. Why do you need long-term storage?
Oh, first, why do we need it at all?
Why does somebody want to go back a year in the past and say, I want to see the memory utilization of my application from a year ago and do something intelligent with it?
Who's that question for?
Whomever wants to answer.
I can answer.
Yeah.
So I think metrics is not just application metrics and infrastructure metrics. Let's start there. You can put any kind of metric. This is completely agnostic. So having container metrics maybe doesn't make sense. But think of trends, right? So you have a service, you want to see trends over the SLIs, over a service, over a multi-year period, something you want for a specific metric, of course, not for everyone. So that's where it comes, like, in the importance of the long term.
What's the example of a trend that takes a year to figure out?
You want to know how well were you performing last year or the 5 years before, and how are you improving over time? It's a thing that you don't notice.
Okay.
There are specific metrics that are really important for that. I mean, there are not many, if I am honest, but there are so many metrics that are important, and it also depends on how much money you also have. There's people that have a lot of money and they want to spend in observability and they want to have that visibility. They do it.
Can you give me the list of those people?
I would like to add on to that. I think apart from people who like setting fire to millions of dollars, it's also people who like to do analytics, because as you mentioned, right, you can store basically any sort of metric. And so if you store metrics about your org specific product or something, you can pull a bunch of data and kind of conduct analytics on it as well. See trends in SLIs and SLOs. I would also say, sometimes you might need to look back on data that is quite old. Often when you discover new issues, and you really want to, let's say you discovered missing data for some time, and you really want to check what happened at 3 months ago. Why do I have missing data right then and there? So observability data is always very tricky data to work with, because you always want the data that you don't have, right, when you're solving things. So yeah,
you don't know what you're going to want later.
Exactly.
Martin
If I may ask a follow-up question,
sure.
what would be then the practice for long-term storage? Do you store everything, or do you filter and say this is the data that I might need in the future, or how does that?
Yeah, sort of like you can filter if you choose to, or you can like store everything. You can also set like retention policies. I think this is possible in Thanos. I think Cortex also has something similar, but yeah, you can essentially say, okay, I will store maybe the raw data for some amount of time and then only store downsample data for the remaining period, whatever your period might be, right? So you can choose to configure. Depends really on your.
One thing to add there probably is the aggregation. You can set up aggregations on metrics, so you don't have to store per metrics per container. That's really useful. When you learn how aggregations can be used, you notice the power, right? Because you just have one series for multiple years, and it's not that much.
And I'm going to draw attention to this comment, which is colorful and memorable to me. Like if you have a security breach and you want to know how breached were you? Yeah. What exactly? How bad is it? And having that data would be...
like going back in time and investigating something. This is exactly the use case, right?
This is very confusing now for me. I understood this is to breaches, so that your customers don't find out.
You made the decision to hide security breaches. We don't want... What security breaches?
I don't know what you're talking about. Yeah.
No, not here. So talking about long-term storage and how it's done. Back to Dan's comment. So let's talk about Prometheus and how long Prometheus naturally stores or can store without the help of Thanos or Cortex.
Well, before I answer that, I just want to say, no, Whitney, no. I didn't have the time to say while you were cutting me off. Oh, no. I thought I had a few more seconds, but I didn't. So this is what you didn't see. I'm joking. If I were to answer this question, I would say that Prometheus is not made for long-term storage. If I'm being honest, it is a great technology. Honestly, I have seen it for up to 12 hours of storing data, and even that can be a little bit of a stretch. It can get very expensive in large architectures. That's why if you are thinking to store data for a long time, you really need one of the friends, Cortex or Thanos, to go for the long term. Don't try it with Prometheus. You will spend a lot of money, and performance-wise, it's not a great idea.
Yeah. What are the friends? That's not the kind of language we want from you. So this one says the only option in Prometheus is to allocate storage to store full resolution data. Is this a different thing? Can you downsample in Prometheus? Or you have to have full resolution? Oh, that's interesting. I didn't know that. Interesting. So then...
Now, if you ask if AWS chooses to sponsor this channel, then the message is don't downsample.
You need everything all the time. So the Prometheus operator being the de facto standard and being integrated with a wide variety of Helm charts in the CNCF ecosystem, using any other tool is a serious challenge except Thanos Sidecar. So it sounds like Thanos can operate on top of the Prometheus that you already have happening. How is Cortex deployed?
It's using Helm. You can use Helm to deploy it as well, yeah.
But like, it's its own standalone tool? Is it running alongside Prometheus like a sidecar like
No,
Thanos
we don't.
does?
We don't need a. No, we don't need a sidecar. You deploy. It's separate from the metrics gatherer, right? You have.
Okay.
You have a collector of Prometheus that gets the metrics and sends over to Cortex. I have to say, Thanos also has that method as well. So to be complete, they can also receive. But Thanos allows you to do the other way that has the sidecar, right? So it has small possibilities.
And so you don't technically even need to have Prometheus running at all. You could be using OpenTelemetry. And then what do you say to Scott's comments about using any other tool? Using Cortex really is a serious challenge because of Prometheus operator being a standard.
I'm not sure that that's what he meant. He meant that many tools, and this is my interpretation, Scott, correct me if I'm wrong, many tools assume that there is Prometheus to do something. Let's say scaling, right?
Okay, I see.
I mean,
Okay.
I would say, I guess, please correct me if I'm wrong, and I know that I might be talking about competition, but you could have Victoria metrics and it's still using Prometheus format, and it would work with those tools
Yeah,
just as well as
I think like
anything
what the
else.
comment says is basically, hey, it's easier for me to configure Thanos sidecar than some other agent on top of Prometheus, because they shipped the option in the CRD.
Okay.
And the reason being, like, Thanos sidecar was kind of really one of the initial implementations that just directly pulled data out of Prometheus. So yeah, if you just enable that everywhere, you can do a central query without running many Thanos components. You just need query, and from the operator you get sidecar. And so yeah, like, it's hard to challenge that easiness, but as kind of Friedrich mentioned, right, like, there are use cases beyond this where you need to run ingesters or receivers, let's say, and people need to push metrics to you, right? So yeah.
I have to start a fight here with that last comment. Let me start one. He says the Prometheus operator is a de facto standard. I disagree with that, because now we have collectors, we have OpenTelemetry collectors, we have a collector operator that can take metrics, logs, traces, and you use that. You don't use the Prometheus operator for that kind of thing, right? So
Yeah, definitely.
So
Yeah,
I think
if
so
you
that's,
aren't using Prometheus, then yeah, obviously, other stuff might appear easier.
Yeah, and OpenTelemetry is becoming one of the
Exactly.
the projects that is growing so much in CNCF. So we cannot say anymore that it's just a Prometheus world, unfortunately. Although I'm in Cortex, I do like Prometheus, so I have to say that. Yeah,
I mean, that is my preference as well, but
I don't want to go against OpenTelemetry because OpenTelemetry is my favorite technology ever in the observability workspace. But for example, we're talking about the target allocator, right? The way I see the target allocator, it's a great tool, but it is kind of built on top of what Prometheus operator does. So it kind of makes still that Prometheus operator is the standard. It is a different tool, a different collector, but it's kind of built on top of Prometheus, let's say.
Will you describe what the target allocator is?
It's a component in the Prometheus operator that, in the OpenTelemetry operator, because there is an operator in OpenTelemetry that kind of does what Prometheus does. It discovers targets, especially in Kubernetes clusters. So yeah, you can use either, but it's kind of the same. Considering it is an operator, it works the same way.
Excellent. And Michael Payne, the first time OTel came up, Michael Payne mentioned it because we have a theory, a hypothesis that we cannot get through a You Choose episode this season without someone talking about OpenTelemetry. But we'll see. Maybe it'll happen. So Scott says Thanos versus Cortex, but I'm going to upgrade this question and say, what is a use case? I'm going to ask each one of you. What's a use case where you would use that's good for your tool particularly? That's like where your tool absolutely shines. So Iris, like, why would someone use Prometheus without one of these friends, as you call them?
It would use Prometheus when you don't have a huge amount of metrics, when you don't have a huge infrastructure and a big number of applications, so that Prometheus can actually manage the storing. But at the same time, when you don't have a huge or like a long retention purposes for more than a few hours, you could use Prometheus. It is great to discover targets, to scrape, to evaluate alerting, CRDs, everything. But when it comes to storage, it is lacking. So if you are going with that intention that, okay, I want to store a huge amount of data, millions of data series, and I want to store them for a long time, you should consider one of Thanos or Cortex in this case.
You're just... We said we want to see a fight. You're supposed to fight. Like, why do we want Prometheus only? So if you're like Victor and you're like, I don't need any long-term data, then maybe Prometheus alone is good. Even if you're going to use it across a big system, even if you want to be able to query all your data at once.
Yeah, you can still use it. You can use a federated Prometheus and have it running on different clusters, and you query it in a federated way. It can happen, yes, it can, but you have to scratch your head very, very hard to make it work. But it will work.
Just a little trickle of blood off the side of your head,
Yeah.
but it'll work. All right, what's a use case where Thanos shines?
I would say like there are two particular ones. The first one being, you're getting started with scaling your monitoring. You have multiple different clusters, and you're now like a global query view. And Thanos, that comment, as it kind of mentioned, is just super easy to enable because you enable sidecar on all of your Promethea, and you just have a central query where you can query on that data. The second use case is when you really operate some really heavy infrastructure that often needs, custom scheduling or custom things as well. And so we have maintainers from like Shopify and Cloudflare who are using Thanos to monitor a bunch of their data centers at planet scale, right, with billions of time series. So yeah, I would say like these are the two primary use cases where Thanos really shines. But yeah.
Awesome. All right, Friedrich, how about you? Where's
Uh,
Cortex the best? Yeah.
So I think Cortex is good for SaaS providers. It's used by one of the biggest SaaS providers, and it's also good for teams that work internally in enterprises where you are like kind of like the SaaS provider of observability for your team, because it kind of helps you define the boundaries, right, between what the long term of the storage of the metrics, the scaling of the infrastructure, and the separation of the metrics, right? You just get the metrics, you don't know what they're coming from, and you just receive them because it's an API, right? Remember, Thanos doesn't have a UI. Sorry, Cortex doesn't have a UI. You have the alerts inside Cortex, and you have everything configured inside Cortex. It's not locally at the client. It's on the server, right? So it's an API basically. It's just an API, yeah.
It's good because for SaaS because it's on the server and because I'm hearing multi-tenancy. Is that true?
Yes.
Is that,
also because you provide multi-tenancy, you have limits per tenant, you have pretty much everything to stand up a SaaS software as a service inside for metrics. So yeah, it's good for that. It's made for that. Yeah.
We have some comments coming through. More comments about why long-term data is good. So power usage over time is a good reason, Victor, to have long-term data. And now that AI is in the picture, being able to train AI on long-term data, maybe?
Yeah, we do that internally, by the way. Yeah.
Oh, yeah,
don't
you do?
say that. Don't say that.
Yeah, I mean, it's exposed as a public feature as well. So yeah, but we basically, it's because I work for like Red Hat and OpenShift. So our update risks prediction feature for our clusters is based on telemetry data from Thanos. So this much I can say.
And Dan McCormick says they're using Prometheus to graph the temperature and the data center, and they like to see trends for different seasons of the year. That's cool. And then Scott was clarifying what I was confused about earlier. Cortex config can work with the Prometheus operator. It's just config, so not an issue. Victoria Metrics, for example, is the challenge as the service monitor. So if you try to use a different tool for your metrics that's not Prometheus, then you're fighting, you're swimming upstream, as they say, because the world is made for Prometheus. Daniel Kim says, such a good panel. You are not helping our fight. Daniel Kim, we'll fight you. And then another antidote, Prometheus and its operator are enough to store 10,000 and more time series for a month for a home lab. Thanos or Cortex if you've got enough memory to manage an entire metrics pipeline. So
I'd say like Prometheus can be pushed beyond 10K. Like I've seen it being pushed beyond 10K, but yeah, definitely when you have, geographically distributed infrastructure or just, a multitude of clusters, at that point, Thanos or Cortex really becomes necessary. But yeah.
So we got through all the questions, but What's a particularly interesting use case that you've encountered, each one of you, that it could highlight your tool, or it could just be like, can you believe someone pushed the tool to this limit to do this thing? Or maybe it's used in a strange way that will entertain us. Yeah, it sounds like you have one.
Yeah, I like, this is not from like my company or anything, but from some other talk that I saw about Thanos. But in essence, there are people who are shipping server boxes, particular server racks, and they gather telemetry from those server racks and push it into Thanos, which is really a very cool use case. It's very unique. Like when people monitor, such scale and such unique things, that really gets me going. So yeah, I'd say that's one particular unique use case.
So now the question is whether their customers know about that.
Oh yeah, they do. Like, they sign an agreement and everything. I don't think doing a public talk in KubeCon without telling the customers was a good idea. Otherwise, right? Yeah.
Friedrich or Iris, do you have one that comes to mind?
Oh yeah, I mean, internal, I do have a lot of experience and amazing things that we have done with Cortex. But the one I'm mostly proud is not about having tons of active series, is actually having less active series. And the reason for that is I don't work for the vendor. We work for a company, and we don't make money. We don't make money for metrics. We make money, if the metrics are used properly. So I'm a big proponent in limits. That's something we use in Cortex, setting up limits for tenants. And we have conversations with tenants when they want to increase their limits. And so that has helped us in our company, keeping that cost down. So I'm really proud not on the number of active series. I know there's a lot of vendors that's like, I have 1 billion active series. We're like, yeah, we are far from that. We've done well. We don't make money for that. That's one thing. Another interesting thing, we got a customer, I don't want to say who, but he was saying they were using Cortex, the single process, right? So we have a mode that's single process. It was made for demos. It was never made. But turns out somebody's using it really well in production. And he was showing us how they were using it in I'm not going to name the company, but they were using it in very large machines. And it was working well for them. They were like, yeah, it's really good. And we were like, yeah, what? It's made for Kubernetes. You're not supposed to use it in virtual machines. What are you doing? So that was interesting. Yeah.
Awesome. And how about you, Iris?
Oh, I have many. To say one for Prometheus and for Prometheus operator, it's like in huge companies. I've always worked in very big companies with like millions of data series being processed. And it's like, people were deploying applications and their metrics were showing up like a magic. So they were like, oh, wow, something is happening. And we actually sat down for a coffee and they're like, oh, it's amazing how your observability platform works. It's like, yeah, I deployed this application yesterday. You guys weren't working, didn't need to do anything. It was already live. And we're like, yeah, okay, let's sit down and talk about this beautiful operator that we have here. It was very fun, because for us, it's common sense how it works. But for an engineer that doesn't care very much about how to deploy metrics, as long as they're there, it's like seeing that magic happen was like, yeah, it's like, wow, Prometheus is great. And I have another story. Actually, it's not about Prometheus, but yeah, I'm going to break the fight here and say about Prometheus and Thanos together, and Victor might get a little bit triggered. Storing metrics for 3 years.
Wow.
And yeah, okay, the computation costs were not cheap, of course, but storage was so cheap because it was like in an S3 bucket. And for 3 years, you were paying that much for the amount of data that were stored. To me, it was crazy when I saw. I was like, wow, okay, that's beautiful.
So do you just downsample more and more the longer it's stored? Yeah. And how, like, realistically, how much do you downsample? Once a day? I don't know. Like, I have no context.
So, like, within Thanos, I believe, like, you can have 2 levels of downsampling. So from raw data, when I talk about raw data, I mean like 1 data point every scrape interval, right? Which could be every 30 seconds or every 15 seconds. So you go from that to maybe one data point every 5 minutes. And you can further downsample into like one data point every 1 hour. Beyond that, we don't really downsample because, like your graphs wouldn't really be accurate at that point. But yeah, we feel like this is enough to get, graphs, but also not melt your computer with samples, right? So, yeah.
We have a question for you, Friedrich. Can Cortex downsample?
No, we have a feature request for that. It could be implemented. We just haven't done it. It's never been important for us. But yeah, if you're thinking of that, you can request a feature. Maybe if user want it, we can do it.
Awesome. Victor and I, we spoke at KCD Zurich, and we met a fellow speaker who lived on a farm, and they set up observability for their cows, and they had a dashboard to show the metrics of the cow's milk production. And it was just like 8 cows on a farm in Zurich, but it was, that's my story of a way observability has been used in an amusing way. So let's, no Thanos needed for that one. I think a standalone Prometheus is probably enough.
Well, above 50 cows. You need 50 cows at least to justify it.
Scott Rosenberg has a question, and this will be our last one. Do Cortex or Thanos support better auth options than Prometheus? So let's do around the table and talk about your auth options. Iris, what's Prometheus do with auth?
I've never used Prometheus with authentication. I've tried and I never managed to make it work. So I can really not speak about that.
I love it. I love your transparency.
If you tried and you didn't succeed, then we can discard that as an option.
It was brought several times, as a feature request for the team. Oh, we need authentication. We haven't been able to make it work. I don't know.
Right on. And how about for Thanos, Saswato?
So yeah, for Thanos again, we support the basic auth option that I think Prometheus kind of also supports, which basically is like an HTTP auth that you can configure. It doesn't amount to much, which is why I think this question exists. But also, when we talk about authentication and authorization, I don't really think it's within the domain of these tools and projects. And so instead, what we recommend is to explore the rest of the CNCF by auth that works. So explore the CNCF. What we do on clusters is basically Cube RBAC proxy, which is this project by Frederick Bronx, and it works really well for us. We can define RBAC essentially for different users to access different things. I believe there's also an OAuth proxy project, but yep.
How about Friedrich, especially since you have that multi-tenancy? I imagine auth is something for you.
It's out of scope for Cortex. The authentication is not something that was implemented in Cortex. Though if you install the Helm chart, it comes with an Nginx that you can use to configure auth. So it's already by default. You can change that, use whatever you want, because what we have is a specification set. If you set up a specific header, that's how you use a specific tenant. So that's specifically how it works in Cortex. That said, there was a request from the community, people that were asking for having a specific auth gateway, and so we kind of did a bit on that. And so we started a project that's called the auth gateway. And that project started. I mean, it's been 2 years. We're yet to release it, but it's about solving that problem as well, because people want to have that integration as well with Cortex. So yeah, it was not in the plan, but people want it. So yeah, that's it.
All right. Well,
Yeah, I mean, with Thanos, there's this other thing called as Observatorium that we have. It is in a different GitHub org, but essentially it's the same thing. It's basically a tenancy gateway with pluggable authentication that you can use. So you can use things like Keycloak with it to authenticate your request to Thanos, and we use it for remote write authentication as well as query authentication and tenancy. So yeah, but it isn't in the scope of these projects, right? So yeah.
Right on. All right, it's time to say our closing statement. So, Iris, why should people vote for Prometheus?
Prometheus is currently the most used observability tool when it comes to metrics. It is the standard in almost every company, or at least a big majority of them. And it brings you so many benefits because you have alerting included, you have self-discovery, and you have a tool that is being supported by so many other engineers that every time that you need some tool or some feature to be implemented, you can always ask or you can always contribute and have it happen. That's the beauty of it. But generally, it's just very friendly with other tools and it fits everywhere.
Amazing. Thank you so much for sharing your time and expertise with us, Iris. Goodbye.
Thank you.
All right, Saswata, why should we vote for Thanos?
So I think there are a couple of reasons I can think of. First is the proven scale. We have users of Thanos running it at planet scale with multiple billions of series, and at companies like Shopify, Cloudflare, Reddit, even Red Hat, where I work. It is acknowledged even to the point where certain parts of Thanos are included in the Prometheus operator. So it makes sense to choose an implementation that can grow with you as you scale. And the second, I think, is just our community, right? We have a wonderful community of amazing users, contributors, and maintainers, some of whom we actually share with Cortex, who are continuously looking to provide feedback and are continuously innovating in this space and are keen to share their knowledge with you.
Thank you so much. Have a wonderful day. We appreciate you. All right. Why should we vote for Cortex, Friedrich?
I said everything that I prefer, but if I might say something to Victor, it's the easiest one you can take because all you have to do is copy what I did for the getting started. It's very easy.
I saw Docker Compose. And I ran away from it like plagues.
In all seriousness, I think we have.
If you have Minikube in or something like that, or kind in getting
we
started,
have also. That's the second part. That's
You
also
win.
there.
No water.
And in general, the community likes to choose whatever's hardest for Victor, as evidenced by vote for Thanos. So Victor has to do more setup.
That's it. If you want to see how hard the Thanos can be, go ahead. Do Thanos.
There's the snide remark after Saswat is off the stage and can't defend himself now. Cheap punches, throwing shots.
I'm to be honest, and being the last one, I'm also being kind of kind. Like Cortex wouldn't exist without Thanos and Prometheus. So we all collaborate. So thinking of Cortex like the last step, I think I kind of like if you could put a Prometheus, a Thanos, and Cortex in the same, that would be amazing. But I don't know if you want to do that. That would be great.
All right. Well, the poll's already live. It's too late. Thank you so much for sharing your time and your expertise today. Goodbye. Well, what a lovely episode that was. Thanks. Yeah. Vote for Cortex so Victor suffers with Docker Compose. So if you're new here and you don't know where to vote, our voting is on the CNCF Slack workspace in the You Choose channel. So if you need an invitation to join CNCF Slack, scan the QR code and you can find your way there. If you're watching a recorded version of this and you want to ask questions, you can ask questions there too. And we'll make sure the guests answer. You could also ask questions in the YouTube channel comments. We'll make it happen. I think that's all we have to say. Next week, we're going to talk about traces, and we'll have Jaeger and Zipkin. Is there anything else you'd like to add, Victor?
Well, Jaeger and Zipkin.
Jaeger and Zipkin. All right. Thank you so much for watching, everyone. Goodbye.